cover over the next few minutes is where artificial intelligence and machine learning analytics have proven to be effective in benefiting the data center industry. I'm going to try and be as agnostic as possible, and there are many different approaches, but here in EchoSense we've been working on a unique approach that includes a selection of analytical tools to solve some industry challenges around efficiency, capacity, space, and cooling. One thing I wanted to put in here as well is about our approach normally and generally is underpinned by industry standards from bodies such as ASHRAE and ETSI and others. But where the AI is concerned, in all its flavors, the standards industry is still learning. This provides great freedom for us to innovate new solutions, which is really helpful, but also suggests that there are risks as well as benefits that need to be considered. And I'm going to try and describe some of these issues as I see them later on. Okay, so our approach is based on 5 simple blocks. We've got to gather some data, we've got to visualize the data, perform some analytics, and then deliver that and repeat. Not all of the vendors in this space are following those 5 steps, but if I go through them step by step, I'll try and highlight what others are doing where I can. Okay, so step 1, and I think all the analytics platforms will agree with this. You've got to gather as much data as you economically can for your application. It's absolutely vital, and everyone will be agreed on that. Exactly how much data you can gather economically is another question, and each different application will have a different ROI on the data you gather, but everyone's agreeing the more data that you can put in there to process, the better the output's going to be. The data itself could come from all kinds of different sources. So it could be custom sensors, something that we specialize in. It could be client sources from their own data. It could be integrating with the cooling machines or the IT systems in the data center itself. It could be public information. It could be weather data from APIs. It could be survey information, all sorts. But broadly speaking, the data can be divided into 2 particular categories. There's a high quality data, which can be validated and verified, and you know where it came from, and you know it's calibrated, and you know what you can do with it. And then there are low quality data sources. Both types of data have uses, but in our application, we tend to be more focused on the high quality data sources, which is one of the reasons why we've had to develop our own series of sensors for that purpose.
And just to reiterate, again, it's that cost of censoring, and we talked about some of the enablers early doors, so cloud, sensors, and really it's that having access to those very, very granular data sets, latest hardware technologies, latest IoT technologies and protocols actually makes this a reality. So it gives you the data granularity requirements that you need at a sensible cost.
Okay, second step. So there are 2 schools of thought on this aspect, so the visualization. So for some players in the market that are using AI, one of the fundamental purposes of it is to remove the human from any kind of involvement in the system, in the process. So there is really no need to worry about the human interaction component of this. You don't really need to see the data if you're processing vast amounts of information to produce a control algorithm, for example. But for us, the opposite is completely true. We want to provide the best sources of data possible and present that data in an intuitive fashion to support the human users in making decisions. So we believe that involving the humans allows for a very special step that's often neglected in AI applications. We want the user to actually learn and develop while interacting from the software, rather than have a distinct black box where things are happening that no one can really penetrate or understand. Both approaches are valid, and we'll talk a bit more about both in a second, but our particular specialty is definitely the visualization of data that comes from the AI.
Yeah, and I think we'd also say that one of the reasons there's some perhaps slightly negative press about some of the types of DC software systems available in the market is they're not particularly intuitive or simple to use or engaging to use. They are not particularly available to or usable for a different mix of audiences. So, and it's always one of the challenges that I think modern systems need to overcome. So you need to very specialist skilled data sets in power, cooling, thermal, how they interact and the learnings from that, but make it's a waste of time if it's not viewable and understandable in a nice, simple manner, and it's not you can't engage with it across quite a wide range of audience in the customer. So that, again, that's the aim of these systems.
Okay, so now we can do some analysis. So very roughly, for the purposes of this discussion, we're going to divide the types of AI that you can do into two broad categories. So these are types where unsupervised learning happens, and then obviously there's a type where supervised learning happens. So the unsupervised learning algorithms are the ones that are normally associated with AI in its pure sense, and they're the neural networks. And they're available systems that can be trained to learn for patterns that deliver a particular positive or negative outcome. So in our industry, that's the classic one, where an optimization goal could be for minimizing cooling power, for example, given some limiting constraints such as rack temperatures. And we ourselves have got a little bit of experience with deep learning algorithms of this type, where we've used them to process object recognition data. So to process numerous thousands and thousands of pictures of frames and racks, and then training an AI engine to process that that information to be able to select automatically when a picture may be of a rack rather than a door or a wall or other things. And the unsupervised learning engines are fantastic at this. One of the great benefits we've got in our industry at the moment for the use of unsupervised learning is coming from the autonomous vehicle sector, where billions of pounds are being invested every year developing that kind of technology, where processing speeds are incredibly rapid. And there's a lot of opportunity to take technology from that sector to try and put it into our sector, where obviously investment and development is much smaller, but we have a use case that's much easier to understand. And this is one of the areas that we'll be looking at closely in the coming years to help us with our how to populate and how to survey rooms more rapidly, how to build 3D models quickly based on survey data. These kinds of tools can be really helpful. So the second type of algorithm, the opposite type, of course, is the supervised learning type. So in our case, we're normally more interested in the supervised learning techniques like machine learning, where the software uses formal engineering maths to interpret huge volumes of data with the goal of learning insights from the data and then communicating these insights to our users. Basically, we want the machine to advise the user and provide guidance on what to do next. But because it's supervised machine learning that we're involved in, we have a great deal of influence over the fundamental maths that goes into the algorithms. So we can control it, we can make sure that the calculations are based upon industry standards, rather than unsupervised learning, where machines could be picking up on any kind of data set from any source that just happens to statistically match the goal that you're trying to achieve. So delivery. So as mentioned, there are two schools of thought on delivery, and in the automatic AI engine, which is delivering a control strategy, for example, you may keep this hidden from view. In fact, you may even restrict humans from being able to view what's going on, because it's not there isn't an easy way to understand how an AI engine is delivering the functionality that it does. But for us, it's all about providing deep insight and actionable advice to any end user looking to improve their site performance. We really want the human to remain the executive agent in our approach. So the types of procedures that we can deliver are very broad. So because the tools deliver insight, the ways that they could be used are as broad and as wide as you can possibly imagine. And in some of the case studies, I'll just give a flavor of how it can be used in lots of different ways. Okay. Yeah, and the repeat, that's because we're focused on empowering users of our tools. It's vital that small steps are taken frequently. So issues where they are detected, and we'll definitely show you a few of those in a moment, should be obvious, but routine action should be interesting and informative and not seen as time consuming. If we're successful in building our analytical tools, it should make operating data centers easier, simpler, and more profitable. And hopefully we'll also be able to show you a little bit later about what the next generation of user interface could look like that could completely revolutionize the way that users and humans are interacting with the physical assets in data centers.
Yeah, I think it's just important to say, just to repeat some of that stuff on there, that it's more than just a one-off approach. So whilst in the past some customers have asked to do a one-off optimization, and of course we can help and solve the immediate challenge at hand, but the dynamic nature of the IT environment, the dynamic nature of changing weather conditions, cooling unit performance, it absolutely has to be an ongoing process, and optimization really does need to be built into the heart of operational processes for the data center.